Bismillahirrahmanirrahim. Rabbi shrah li sadri wa yassir li amri wahlul uqdatam min lisani yafqahu qawli. Assalamu alaikum students. This is Hamza Noor, and today here we are with a question from the topic log and exponential. The concept is the linear relationship of log, and this is relevant for A2 Maths P3 A-level Maths 9709. So the question is from the attempt June 2013, paper 3-2, question number 3. The question says that the variables x and y satisfy the equation y is equals to a multiplied by e raised to the power minus k x square, where a and k are constants. The graph of L and y against x square is a straight line passing through the points 0.64, 0.76 and 1.69, 0.32. As shown in the diagram, find the values of a and k correct to two decimal places. All right, so first of all, the equation is y is equals to a multiplied by y is equals to a multiplied by e raised to the power minus k x square. So first of all, you have to introduce ln on both sides. So ln y is equals to ln, and the term in the ln function is a multiplied by e raised to the power minus kx square. Okay, because we need to introduce ln because the graph of x square against ln y is given to us. Okay, so if we apply the product law, if we apply the product law over here, so ln y is equals to ln a plus ln e raised to the power minus kx square. Okay, now if we arrange the terms like this, ln y is equals to ln e raised to the power minus kx square and then plus ln a. This is the same thing. Now according to the power law, okay, this whole power can be written as a constant term over here. So ln y is equals to minus kx square multiplied by ln e and then plus ln a. And since you know the fact that ln e is itself equals to 1 because log to its own base, because ln itself is log with the base e and ln e will be log with the base e and then term e. So when log is raised to its own base, that is equals to 1. So ln e is therefore equals to 1. So your equation is now like this: ln y is equals to minus kx square plus ln a. So far we have achieved this equation. Now what you need to understand over here is that the graph of ln y is made against x square. As you have already studied the concepts of coordinate geometry in O-level maths and IGCSE maths. For example, if the graph of y against x is given, so you have the equation of the straight line in the form of y is equals to mx plus c. The y is made the subject, and then whatever the coefficient of x is, that is known as the gradient. But the condition must be that the y is made a subject. I mean, for example, if a constant term is being multiplied by y, so you have to make y the subject. So in this case, you know, y, you have to make y the subject in order to exactly know what is the gradient, and that gradient would be the coefficient of x. So here ln y against x square is made this, I mean ln y against x square is given to you. So I would say that when ln y is made the subject, so whatever the coefficient of x square is, that will be considered as the gradient. As simple as that. Okay, so here now ln y is made the subject, so whatever the coefficient of x square is, that is considered as the gradient. So minus k is the gradient over here. Minus k is the gradient over here, and since we know the fact that line is a downward sloping line, so the gradient is supposed to be negative. So we can say that the minus k is actually the gradient of this line. So how do we find the gradient of this line? We have two coordinates. I mean, previously in the basic concept of the coordinate geometry, the coordinates were given to us in this form, x comma y. Now in this case, the coordinates are given to us in this form, x square comma ln y. So according to the formula of the gradient, what we can do, y2 minus y1 over x2 minus x1. But in this case, we would say that ln y2 minus ln y1 over x square 2 minus x square 1. So we don't need to exactly mention this whole thing, this formula. We can just directly find out the gradient. So 0.32 minus 0.76 divided by 1.69 minus 0.64. So we can actually find out the value of the gradient, and that will be equals to minus k. 0.32 minus 0.76 divided by 1.69 minus 0.64. This is minus 0.419. So the gradient is minus 0.419 and gradient is actually minus k. Therefore, we can say that k is equals to 0.419, but the requirement is correct to two decimal places. Therefore, k is equals to 0.42. K is equals to 0.42. Now we need to find the value of a. So our equation is in this form. ln y is equals to minus k times x square plus ln a. Okay, and since we know the fact that the gradient is equals to minus 0.419. Okay, I'm writing this gradient correct to three decimal places so that my final answers come more accurate, correct to two decimal places. I mean, the value of k was required correct to two decimal places, but since you are using it in your further calculation, so it is recommended to take up to 3 to 4 decimal places, so your final answers come more accurate. Okay, so ln y is equals to minus 0.419 times x square plus ln a. Now we need to actually find the value of a, right? We can take any of these 2 points over here. Let's say I'm going to take 0.64 comma 0.76, and those students who are watching this recording, they will take this point and we will get the same answer for a, because these 2 points are actually satisfying the equation of this straight line. But don't forget the fact that the coordinates are given to you in the form of x square comma ln y. The coordinates are given to you in the form x square comma ln y, not x and y. So I am taking 0.64 comma 0.76, and those students who are watching this recording, they will take the coordinate 1.69 comma 0.32, and we are going to follow some steps. We are going to put these values into this equation and we will achieve the same answer for a. Okay, so the value of x square is 0.64 and the corresponding value of ln y is 0.76. So 0.76 is equals to minus 0.419 times 0.64. This is the value of x square itself, and then obviously plus ln a. Okay, so just simplify this. 0.76 plus 0.419 times 0.64 is equals to ln a. So the value of ln a is 0.76 plus 0.419 times 0.64. The value of ln a is 1.028. 1.02816. Now you need to find the value of a. So ln is itself log with the base e. So when a is made the subject of this equation, so a is equals to e raised to the power 1.02816. So e raised to the power your answer, and a is equals to 2.795. So I mean 2.796, but correct to two decimal places is required. So a is equals to 2.80. So this is how you solve these type of questions, where the concept is the linear relationship of log. And those students who will take this point 1.69 comma 0.32, they will definitely get the same answer.